So this is going back and knowing what your perfect cubes and your perfect squares are. I know we've talked about that in the past, but we can review those as well as we go through these notes. If your index is even, so obviously you know even is 2, 4, 6, 8, 10, so on and so forth, then we actually have 3 options that happen here, okay? So if your index is even and you have a number, a radicand, a number inside your radical symbol that is greater than 0 or positive, we will have 2 solutions, okay? So an example of this would be 4th root of 16. Well, what number times itself 4 times gives us 16? Well, that would be 2. But that would also be negative 2, because negative 2 times itself 4 times also gives us 16. So we would write our answer is positive or negative 2. You also know this in terms of square roots, right? If I took the square root of 25, 5 times 5 gives us 25, but negative 5 times negative 5 also gives us 25. So we would have an answer that would be positive and negative 5. So if you have an inside number that is positive, which is greater than 0, and you have an even index, you will have 2 answers, a positive and a negative. If you have an even index and your inside value is 0, so your radicand is 0, you will only ever have 1 solution, and that 1 solution will always be 0. So for example, the 4th root of 0 is 0. The square root of 0 is 0. So any even, actually any one of them, even if it's cubed or to the 5th power, if you take that number and you're taking the whatever root of 0, you will always have 0. We didn't need to talk about that above because the cube root of 0 obviously is 0, and we have 1 solution, so that still works up here. If we have a negative radicand, so a number less than 0 inside my radical symbol, and I still have an index that is positive, I'm going to have no solution. And you guys can remember this back to what we talked about in Unit 2, or I think it was Unit 1, when we talked about imaginary numbers. If I have the square root of negative 25, we know that we can't take the square roots of a negative number, so this would give us a positive or negative 5i, which we know to be not a real number. So anytime that you have a even index with a number less than 0, which is a negative, we will not have any real solution. If you notice, if you have any real number, it can be positive or negative. For an odd index, it's not going to matter. So odd indexes, it doesn't matter. It only matters if it's going to be a positive index.